All right, folks, welcome back to College Algebra. And as promised, we're going to do a bit of a homework walkthrough for section, what's this, 3.4, I believe, 2.4. Okay, so it starts off pretty tame, all right? All they're asking us is how many zeros could we possibly have here, right? And because we have a degree of 10, right, what they're saying is, did you read the chapter? Really, that's all they're really asking you here. So we could have 10 possible zeros, okay? If we count them all twice, if we count them all correctly. Let me see if we can find another one. Okay, this is a nicer one. So this one, right, we might even have a chance at this, finding these. But we have 6x to the 5th. I don't really care about this stuff, right? It's just we have 5 possible zeros here because we're just looking at the degree, right? That's all we're checking. Okay, number 2. Okay, we're going to pull up our little sheet here for this one. Okay. So g of x is a polynomial with real coefficients, and we have x equals 3, right? So we have x equals 3. And how many times does this happen, right? Multiplicity 1. Okay, we have x equals -4, and this happened twice. Okay, then we have 5i, right? So x equals 5i. -4. X equals 5i. So I know that automatically that 5i is, since 5i is a 0, that -5i is also a 0 because it always has the conjugate. So how are those conjugates? Well, it's 0 plus 5i and 0 minus 5i. Okay, so the middle sign changed. So we have another 2 zeros there. And the last one is x is equal to, right, 3 plus 4i. And because of the conjugate theorem, that we know that 3 minus 4i is also a 0, right? They always come in pairs. So we're going to get that 0 as well. Okay, so the minimum degree, right? 2, 4, 6, 7. Okay, so 7. All right, another one. Right. So in this case, right, we have a 0 of 5. So that means that x equals 5. That happened one time. Okay. We have x equals 3, right? That's a 0. And that is also one time. Okay, because we have 3i, right? We have x equals 3i. But I know because of the conjugate pairs, right? X equals -3i is also a 0 because these always come in pairs. X equals 4 plus 6i. Well, we're also going to have an x equals 4 minus 6i, the conjugate. So this again comes twice. All right. So what's the minimum degree? We have 2, 4, 5, 6. Degree is 6. And then there we go. All right. Next one is a little bit harder. All right. We are given, we have 9x cubed minus 167x squared plus 828x minus 410. Who comes up with these numbers? And 9 minus I is a 0. Okay. You say, oh, delightful. I loved synthetic division. I haven't had a chance to do enough of it. And we get to do it with complex numbers. Nobody should be allowed to have this much fun. Okay, so I'm going to go ahead and spread these out a little bit because I know that these values are going to be complex numbers. So we need some space. Okay, but what is that? We need negative 167. We need a positive 828, and then a negative 410. Right. So the synthetic division rules apply. It doesn't matter about this, right? We just bring that 9 down. Okay, now we're going to take whatever we have here and multiply it by 9. So we have 9 minus I times 9, and that is equal to 81 minus 9i. Okay, so that is 81 minus 9i. Right? And we're just going to add. Okay. Excuse me. So what we have here is we have the 167 minus 81 So we get a negative 86, right, minus 9i. Just added them, okay? Next step is to take whatever we have here, right, the original c here, and we're going to multiply it by that. Okay, so get ready. This is going to get more fun at this point. All right, we have a negative 86 minus 9i. All right, so my firsts, right, that's 9 times 86. So 9 times 86 here. Right, that was 774. All right, that's my first term. Oh, it's negative. Don't forget that. Okay, we have a positive 86i, right? That's my inners. My outers is going to be a negative 81i. And then my lasts are going to be plus, right? Negative times negative is positive. And that's going to be a 9i squared. But it's really going to turn into a negative 9, isn't it? Because this is negative 1 times 9. So let's go ahead and group them. So we have negative 774 minus 9 plus 86i minus 81i. Okay, so what do we have here? 774 minus 9, 774 plus 9 rather. They're both going in the negative direction, and that looks like 783 negative. And what do we have? 86 minus that is going to be a plus 5i, it looks like. All right, so let's go ahead and put this up here. So we've got negative 783, right? And then plus 5i. And we're just going to add. So we have 5i here, right? And that's going to be what? 828 minus 783, 45. Right? Now we're almost there, right? We have one more to go. So this is going to be 9 minus I. Now we have 45 plus 5i, I believe. And we have to multiply through by that. So 9 times 45. Right, that was 405. All right, we have a minus 45i. We have a positive 45i, who would have thought. And then we have a minus 5i squared, but that's going to be a positive 5 here. All right, so that's going to be 405 and 5. That's one I can finally do. It's 410. And those canceled. So we just have a 410 up here. Hey, would you look at, I mean, they didn't lie to us. They don't, your book does not lie to you, at least not very often. Okay, so, you know, we started off with x cubed, x squared, x, and a constant term. We divided, we have an x squared, an x, and a constant term. So if I wanted to write this out, right, this would be 9x squared, right, plus negative 86 minus 9ix plus 45 plus 5i is my constant. So this is still a parabola or quadratic, except now it's over the real, or it's over the complex values. So life gets more interesting, but that's how you would read this off. Okay. Since I know that this is now a 0, I also know that 9 plus I is a 0. Okay. We have 9 plus I, and we're going to go through and do that on the abbreviated format, right? Because we're trying to get down to like figuring them all out. So, you know, if we know that 9 minus I goes into this, we're going to know that 9 plus I is going to go into this mess. All right, so we're just going to take the abbreviated, we're going to take the reduced form here. Okay, so that is what? That's 9. And then what do we have here? We have, what was this? This was negative 86 minus 9i. Okay, and this was 45 plus 5i, I believe. 86 minus 9i and 45 plus 5i. Same synthetic division rules. This comes straight down. We're going to go ahead and multiply. So it's going to be 81 plus 9i. Right? And we ended up with what? We ended up with negative 5. we're going to multiply again. So we get negative 45 minus 5i. Hey, would you look at that? 0. Okay, so what we have, right, this start off with an x squared, it goes down by 1. This is 9x minus 5 is equal to 0. That's what we need to solve next. So 9x is equal to 5, x is equal to 5/9. All right, so the 3 zeros we have, right, we have the one we have the one they gave us, the one we checked on, and we knew it was going to be there anyway. But we needed this, right? We needed the 9 plus I in order to break the last one. All right. So those are my zeros. Let's see what else they ask. All right. So let's see here. Find all the zeros. Well, if 9 minus I, okay, comma, we have 9 plus I. I mean, I could have filled that out at this point, right? I didn't need to do the division to know that that was going to be true, right? But I never would have found 5/9, right? That's what it is. I never would have found 5/9 if I didn't check, right? That is the whole point. All right. And then write them as a product of linear factors. They don't tell us that we have to do integer values here, so I think we can just go ahead and say x minus 5/9, and I think it'll take it. Right? And then here's what we're going to do. We're going to say x minus, all right? And then I usually just put this in parentheses, x minus parentheses 9 minus I. Oops, I need a 9 minus I. Oops. Okay, a lot of times we'll use brackets for this instead, but you know, that's fine. Actually, can we use brackets? By the way, I know from previous experience that if I use brackets around the x minus 5/9, it gets mad at you and it won't let you do it. It'll mark you wrong. And x minus, now what's the conjugate? 9 plus I. That's why I would also recommend like very liberal use of parentheses here, because it is hard to keep all of this stuff straight in your head to do it. Okay, oh, I didn't like that at all. Let's see. 9 minus, or x minus 9 minus I, right? And then, oh, I didn't like this one. Wish it gave me a little bit of a hint. Well, I wonder, oh, as a product of linear factors, I don't know. That might be a 9 minus 9x minus 5 here. All right, let's see about that. Oh, so that was the right answer. Okay, there we go. So yeah, you have to be careful about how they're going to want this phrased. All right, and the solution set, right? We're just going to write down the zeros. Okay, we're just going to write down the zeros. So we have 5/9, comma, oops, 5/9, comma. We have 9 plus I and 9 minus I. I mean, it's kind of redundant, right? They already asked us to do all of that. It's like, here are the zeros, and then rate them at a different point. Like, all right, I don't know why, but there you go. All right, let's see here. Okay, 2 of the zeros are given. So really, we have 1 0 here, which is real, and then 2 more here. So we have 3 zeros. Really, we'll go down to a quadratic, which we know we can solve in order to solve this one. All right, so let's go ahead and do that one. All right, so yeah, we are going to do some heavy synthetic division on this one here. And yes, I did pause to make sure I would do this correctly. So let's see here. Let's write this thing down. All right, so we had 4x to the 5th, 23x to the 4th, plus 26x cubed, 72, negative 72x squared. Oh man, minus 240x. I got news for you. This looks so much fun. Right? We should not be allowed to have this much fun. All right, and we're given that negative 2 minus 2i and 1/4 are both zeros. All right, I'm going to go after the quarter first, hoping that maybe some of these numbers get a little smaller. Right? We'll hit the imaginary one next because, first off, if the quarter is a 0, we can knock this down to an x to the 4th, so there'll be one fewer term, and that way when we go with the complex one, right, there'll be a little bit less. So that's how we're going to tackle this. All right. Quite honestly, I think I'm saving myself some time here. I haven't tried it the other way yet, but I have a feeling that no matter how we tackle this, it's going to be a mess and it's going to be delightful. Okay, so let's go. We've got 4, 23, 26, negative 72, negative 240, 64. And then we're going to make our little synthetic division piece here. And we're going to put in a quarter. Right? So the 4 drops down. 1/4 times a quarter. 1/4 times 4, that's going to be 1. Add them together, it's 24. 1/4 of 24, that's going to be 6. Add them together, it's 32. 1/4 of 32 is 8. Right? Now, we're at negative 72 plus 8. Negative 64. Okay, 1/4 times 64, that's going to be negative 16. Careful with your signs here, by the way. That's if you're going to mess it up, that's where I mess it up. Just careful with your signs. That's 256. 1/4 times 256 just happens to be 64. Keep your signs negative. And what do you know? They didn't lie to us. It is a 0. Okay. But notice this started off as an x to the 5th. This is now 4x to the 4th. It's 23x to the 4th. It's now 24x to the 4th. All right, so did the numbers get better? Not really, but there we are. All right, next. Negative 2 minus 2i. Okay, honestly, this reminds me of my pre-calc teacher because he would love to give us problems that were just, you'd end up doing a whole bunch of these things. They were all really awful. And in the end, the way they tell us about this thing here, this is all like how to find rational roots, right? Until you get down to the end where you can get the irrational ones with the quadratic formula. But if there's an irrational root before that, then you're not getting anything. And if all the roots are irrational, then there's no way to crack this egg, right? There's no way to start cracking it. So yeah, a lot of our problems were just you don't get an answer. Like after all of this, your answer would be like, nothing worked. Like, what do I do? He's like, just tell us that nothing worked. There are no rational roots. That's your answer. Like, I did 16 of these. What do you mean there aren't any? Sometimes there aren't any. Was there an easier way to like teach us the philosophy of nihilism than just making us do like 16 problems like this and not have an answer? Like, honestly. But there it is. Right. I don't remember which philosophy there is, but like what's one that says like you don't grow unless you experience pain. So maybe it was good for us, right? All right. What do they say? Builds character. All right. So now, speaking of building character, okay, we have to multiply this out. Now, there is a slightly more clever way to do this. I'm going to show you what it is, but I'm going to assume that none of you are really going to see this as a more clever way. But if I can convince you to like start looking at it this way, you might have a chance to do this in before you die of old age. Okay, notice that this is -2 minus 2i, so that's -2, and I have 1 plus I here. And then this is 16 and 8, so if I pull out an 8, right, 16 divided by 8, that's 2, minus I, right, this is equal to -16, 1 plus I, and then 2 minus I, and then multiply this together because the numbers are small, and then multiply it by 16 when you're done in order to put it back up here. All right. So I'm going to renege on that. I'm going to say, you know what? This looks far more attractive than this. Right, multiplying this out just looks horrible. This one, maybe that's the lesson. Right? So under enough adversity, you will find simpler ways. So that's 2. We have a plus 2i, right? We have a minus I, and then we have a minus I squared, right? So we have 16, 2 minus I squared, right? That's plus 1, isn't it? And then we have 2i minus I. So 2 plus 1 is 3. 2 minus 1 is 1. -16, and we ended up with negative, right? 16 times 3 is 48, minus 16i. All right, so if you multiply this out, you're going to end up with the same thing. I know. And, we'll be in the same spot. So that's okay. All right. So that was this. Then we're going to have, what do we have here? We have -16, -48 here. Okay, minus 16i. Yeah. And then we add. Okay, then we add. So we end up with 32 minus 48, and that was -16. Okay, minus 16i. All right. So I'm going to go down here. We have -2 minus 2i. And then here we have, right, -16 minus 16i. So again, right, if I pull out a -2, that's going to be -2 times 1 plus I. All right. I pull out a -16 here, and then what do we have? We have 1 plus I. All right. So 16 times 2 is 32. Negative times negative is positive. And now we have to deal with 1 plus I, 1 plus I, right? Which is 2, or I'm sorry, is 1 plus I plus I plus I squared. Okay. And we'll get 2i here. 1, and then this is -1. That'll cancel out. We've got a 32. Okay. So we ended up with, right, we ended up with 64. Okay, so here we are, 64i. There's not really a lot to add here, is there? -64 plus 64i. Looks good. All right, next round. So, well, not next round, next moment. Right, and then what do we have here? We have -64 plus 64i. And I'm going to do that same trick. I'm going to say, hey, this is -2. All right. This is 1 plus I. And then we have 64. Right? We can pull a -64. That's fine. Pull a -64. We have 1 minus I. Right? You may have noticed, I mean, before this, you guys may have noticed, like, hey, isn't that the conjugate? Like, yes, it is. So that's going to be negative, right? That's going to be 128. Okay, and then we have 1 plus I, 1 minus I. Okay. This is going to be 1, right? Notice the I and the negative I cancel, and we end up with negative I squared, right? Which is -1. Negative 1 is 1. So we have 2. These guys cancel, and we just have negative 128 times 2, which is negative 256, which is so convenient because look what happens here. All right, I may have dropped a sign because these should have let's see. They shouldn't. Oh no, this was positive 256. What happened? Oh, the -2. I forgot the negative 2 times that is going to be. We put out a -64, remember? So that's going to be a positive. Okay. I know it works. So there we go. We end up with 0. Of course we do. All right. Now, since -2 minus 2i was a root, -2 plus 2i is also a root. Okay. So -2 plus 2i also goes into this mess. And all we're going to do is pull these coefficients down and put them down on the ground here, put them on the next coefficients. So that's 4, right? And that's, right, here we have x to the 5th, and we have x to the 4th. This one is 4x cubed. Okay, 16 minus 8i. Right. Next one up is -16 minus 16i. Right. And then we have -64 plus 64i. Right. And we're ready to go. Okay, so this is 4x cubed, 16 minus 8i, x squared, -16 minus 16i, x's, minus 64 plus 64i as our constant. Okay, so same rules, 4 comes down, right? And now we, the wheels turn again, right? I'm just going to grind this out on the right page. All right, so this isn't so bad, right? This is -8, right? And then -8i. Oh no, positive, right? 2 times 4 is positive. So let's go ahead and do that. That's 8, and that's 0. That's encouraging. Okay. So now we have to do -2 plus 2i times 8. So that's going to be -16 plus 16i. Again, that's very encouraging, right? -16 and -16 is -32, but there's no imaginary parts here. Right? And then we're going to have 64, right, minus 64i. Oh, what do you know, that just turned out to be 0. So what do we have left? We have 4x squared plus 8x, right, minus 32. Right? I sense a common factor here, right? Because we have to solve this for 0. So let's go ahead and pull this out. So we've got 4. We've got an x squared plus 2x minus 8. And I think we could say that this is going to be x plus 4 and x minus 2. Right, that's minus 2x is plus 4, 0. X is equal to -4. X is equal to 2. Okay, so here are our zeros. The zeros were x is equal to 1/4, right? X is equal to -2 minus 2i. X is equal to -2 plus 2i. X equals -4. X equals 2. 1, 2, 3, 4, 5 roots, 5 zeros. All right. So that is going to be our answer for this one. I hope this one helped. I hope you guys, well, actually, I hope it didn't help. I hope you do not have one that is nearly this awful. But if you do, I hope you will be able to follow along with the homework here as the video and check your arithmetic with me and make sure that you're doing everything correct here so that hopefully you will only have to go through this painful process once. All right. But remember, it builds character, so you should go through it once. Okay. Honestly, I hope you don't have to. This is terrible. Okay. So the zeros. Okay. I am not even going to pretend that this is going to work out perfectly for me. Okay. So 1/4. I know the smallest slip. What did we have here? We had -4 and 2. Okay, that would deal with the easy ones. And then we have -2 minus 2i, comma, -2 plus 2i. Holding the breath here. All right. Write them as a product of linear factors. I don't want to. All right. What do I mean by product of linear factors? This means this is x minus 1/4. This might be, right, 4x minus 1. I don't know exactly how they're going to want it right now, but either way, right? These are pretty easy, right? This is x plus 4. This is x minus 2. The way I would do these is x minus, right? Because we're bringing this over. And I would put a thing in here, and I would say, okay, -2 minus 2i, right? Because we would bring this over. And I wouldn't worry about trying to distribute that, okay? It's a complex factor. Just leave it alone. X minus, and then we have -2 plus 2i. I mean, you can, right? We could put this in here. We'd have, right, x plus 2 plus 2i, x plus 2 minus 2i. So that's not going to hurt anything, right? And now that I've done it, I might as well keep it, right? So let's see. I wonder if they'll let me get away with this. That's 4x plus 1. All right, we have an x plus 4 and x minus 2. X minus 2. We have an x plus 2 plus 2i. And x plus 2 minus 2i. Okay, just trying to read them off of this thing. It takes a little bit of practice to put these back into the order that they actually want, to distribute through this and to write it down in general. Okay, it does take a little bit of practice. So if you're getting a little bit stuck here and the signs aren't quite working, it'll come. All right, but it does take a little bit of practice. Okay, check. Didn't like it. I'll bet it's here. X minus 1/4. All right, let's see if that goes. Still doesn't like it. I'm just gonna punt. I'm gonna say, you know what? Because I'll bet. All right. Oh, it did like the 4x minus 1. It was okay with the x minus 2. It was okay with the x plus 4. But it really wanted me to leave them in these parentheses like this. Okay, so if you multiply these out, we did bad. Okay, they wanted us to leave them inside. So be it. Okay. Solve the equation, write the answer in exact term. We already did this. Okay, these are the zeros right here. Okay, we're done. Okay. So all it takes is write them down correctly. Oops, not there. Okay, put the 4 there, then a comma. All right, then we have a 2. Then we have a -4. Then we have a -2 minus 2i, comma, -2 plus 2i. All right, that should be everybody. All right, and now they're happy. Okay, so on this one, again, it's a more of a, I would hate to do this problem again. So watch this, learn from my mistake. They know that they want this in a bracket kind of a thing here. All right. So I am gonna go ahead and say I think this is enough for the first walkthrough. I'll do 5, 6, 7 next time, And I will wish you well with that. All right. Take care.